Power to the Pico, the guide to everything you need to know about powering your Raspberry Pi Pico. This video will cover all aspects of powering the Pico, from powering with USB, use of batteries, and even more obscure options if you need to power the Pico with renewable energy. This is inspired by my current project. For this, I needed to use an external power supply to power the Pico, but I also wanted the option to update the code using USB, and I didn't want to damage either the Pico or the computer it was connected to. More on that later. I'll be covering the power supply requirements for the Pico, the voltage range, etc. Understanding what the different power pins do. So if you don't know the difference between VBUS and VSYS, then you will know by the end of this video. Include a look at the schematic diagram of the Pico, specifically looking at the power section. Looking at how you can power directly through the pins of the Pico and how you can safely use that with or without USB connected. And then some special considerations about how you get your power, how stable it is, and how you could save power by bypassing the protection diode. The source for the power information is taken from the Raspberry Pi Pico datasheet. It's not the easiest of documents, so I've pulled out the relevant information and provided it here. I'll also be looking at the internal circuitry of the Pico and the differences between the Pico and the Pico W. In most cases, you can take the specs as being the same for the Pico W, and I'll explain where there is a difference. The first thing to look at is VSYS, the system voltage for the Pico. We'll look at which pin this is later, but the recommended voltage is between 1.8 and 5.5 volts. This means that you can use an external power supply between 1.8 and 5.5 volts, which could be mains powered, batteries, or anything else. Or if you're using VBUS, such as using the USB power supply, then it should be 5 volts plus or minus 10%. Why did I give one voltage as a range and the other plus or minus 10%? I could have said 4.5 to 5.5 volts for the second, which essentially means the same thing. It's more convention than anything, but effectively VSYS allows you to use a different range of power supplies depending upon your use. But VBUS should really be 5 volts. It just allows a small tolerance because in the real world you'll experience different voltages. However, saying that, when we get to look at the circuit, you'll see that there isn't actually much difference between VBUS and VSYS. You could in fact run with a much lower voltage on VBUS rather than the official standard of 5 volts. The current draw used by the Pico depends on a lot of different factors. There are some measured values in the specifications, including some details about the low power mode. I've just used one of their values, which is the top end of around 95 milliamps, which is when running the Popcorn media player on a VGA video board. Note that includes the VGA board in the current measurements, so the amount that the Pico draws is going to be less than that. The lower end of 18 milliamps is just what I measured using the basic program, which was flashing the onboard LED. In reality, for most programs, then the power will be somewhere in that range. With the Pico W, then I measured an extra 10 milliamps when it was not connected to a network, and an extra 20 to 30 milliamps extra when it was connected to a wireless network. Again, these could fluctuate significantly depending upon what you're doing. There are some ways to run the Pico at less power by using the sleep and dormant modes. These may be useful if you're looking at very low power setups, or we'll look at another alternative later that you can use to completely shut down the Pico. See the datasheet if you want more details about these low power modes. For the maximum recommended current, this is from the 3.3 volt output, I've used the recommendation from the Raspberry Pi datasheet of 300 milliamps. Based on the components, you could likely exceed that, although it may result in unwanted heat in the buck boost converter. If you need more than that for external circuitry, then you're better off powering the Pico from an external power supply rather than the circuit from the Pico. I'll provide details of how to achieve that later in the video. Now, you certainly won't get anywhere near this amount out of the GPIO pins. The total of all the GPIO pins needs to be less than 50 milliamps. I'm just talking about the power pins in this video. So, in summary, we can use a power supply between 1.8 and 5.5 volts, or we can power from a USB at 5 volts. For most circumstances, then a 100 milliamp power supply would provide all the power that the Pico needs. And for low power situations, you can get away with much less. The maximum current we can use from 3.3 volt output is 300 milliamps. Now we can take a look at the different power input pins and see how we can provide the power to the Pico. We can start by looking at the USB connector and VBUS together. The reason is that these are directly connected together, literally. As you can see from the schematic diagram, USB connector pin 1 goes straight to the power label VBUS. The small square boxes shown in this diagram are the test points, which are made available as pads on the back of the Pico. As per the specs, they should be connected at 5 volts with a tolerance of plus or minus 10%. If you wanted to use an external power supply to VBUS, I suggest using the USB connector rather than connecting to pin 40. The reason for this is that it prevents you from connecting two power supplies together. For example, if you connect an external power supply, but then realise you need to do an update to the code, so you connect it to your computer, in that case you have the USB power from your PC and the external power supply connected together. One way this can be useful is if you want to use it as a 5 volt power supply to power some external circuitry. For example, if you have some 5 volt RGB LEDs that you want to power from the USB power supply, be aware that this is directly connected to your USB power supply, which, if programming, will be your computer. So do not use this if you need a lot of power. So here's an example, and this is using VBUS connector as an output to power your own 5 volt circuits. And as I say here, I've got two RGB LEDs, also known as NeoPixels. The NeoPixels take their power supply from the VBUS on pin 40 and the ground on pin 38. Note, you should not use this for long NeoPixel strings, which would need more power than the USB supply is designed for. I've used the GPIO 3.3 volt output to send the data signal to the NeoPixels. The NeoPixels actually expect a 5 volt data input, but in reality this will work on this breadboard layout at least. I've created other videos and guides explaining how you can use a level shifter if you want to increase that to 5 volts. I do not recommend you connect an input voltage directly to pin 40. There's a chance it could be connected via USB. There's a much better way of doing that, which we'll see next. The risk of doing that, so you could either be backfeeding power to the USB power supply, or that the USB power supply could be trying to drive your own supply. If you're sure you won't be connecting this to USB while powering it, then you could actually take this voltage much lower than the recommended. But again, there's a better way of doing that, which is using VSYS, which we're going to look at next. The more useful pin, if you're looking to power the Pico from an external power supply, is pin 39, the VSYS pin. This is the system power. In the event that you're powering through USB or the VBUS pin, then this is derived from that VBUS supply. The one thing that is provided between VBUS and VSYS is a protection diode. This will protect against incorrect polarity and prevents backfeeding power to the USB power supply. And this is the relevant part of the schematic diagram which shows that. The main thing to be aware of is that the diode is in the centre of this diagram, and this protects VBUS, the USB input, from those back voltages from VSYS. There's also a potential divider which will give a high value on GPIO 24 when VBUS is used, and the resistor to the right of diode is a pull-up resistor for the buck boost converter, and then there's also a smoothing capacitor on this diagram. But essentially the main thing is this diode. Pin 38 is the ground pin. This is one of several around the board. I've specifically highlighted this as it's adjacent to the other power pins we've been looking at. Hopefully it's very obvious whenever you connect an external power supply or use the Pico for connecting to external circuitry, then you're going to need to connect to a ground pin as well. If not, I do have a beginner electronics section on my website, penguintutor.com. Pin 37 is a 3.3 volt output enable. For most purposes you don't need this pin, but I will come back to it later on in the video. Pin 36 is useful if you want a 3.3 volt power supply for any external circuitry or components. It's specifically designated as an output, but it's also directly connected to the 3.3 volt supply for the RP2040 microcontroller, which is on board the Pico. It's actually taken from a buck boost converter, which is powered from VSYS. There is a recommended maximum of 300 mA from that converter. Looking at the components, you can probably take it much further. The buck boost converter for the Pico can handle 800 mA, and it's even more for the Pico W version. I suspect the limit of 300 mA is due to the risk of overheating if you use too much current. If you find that you need more than 300 mA, then it's probably a better way of providing that using a different method, such as an external power supply instead. Let's take a look at the buck boost converter. This is the full schematic diagram of the power section. We've already covered everything to the left of the buck boost converter, so let's concentrate directly on the buck boost converter itself. The main part of this is the RT6150B and the -33GQW buck boost switching regulator. And this is the part specifically used on the Raspberry Pi Pico. The Pico W uses a more powerful version, but it's otherwise very similar. This makes use of an inductor, which provides a way of increasing or decreasing the voltage as appropriate. If the input to the buck boost converter from VSYS is less than 3.3 volts required output, then it will work in a boost mode to increase the voltage to 3.3 volts. If the voltage input is higher, then it will work in a buck mode, reduce the voltage down to 3.3 volts. This is an efficient way to convert DC to DC voltage. It certainly wastes much less energy than using a linear voltage regulator. I'm going to look at some ways of powering either the Pico from an external power supply or powering external circuits from the Pico. Rather than using schematic diagrams which I've shown from the Pico, I'm going to show these as breadboard circuits. Some of these are based on real circuits that I've created as examples for this tutorial. The first example is one I showed earlier in this video, which is using the 5 volt VBUS to power external components from the USB connection, which you're using to power and or program the Pico. This is shown here with the VBUS being used to power 2 NeoPixels. If you're using this, then you need to be aware that the components will be drawing all their power from the USB power supply. The only protection being that built into the USB supply that you're using, such as your computer's USB or perhaps a USB power bank. If you want to connect to VSYS, then you can use that instead. The only difference would be a small drop in voltage due to the diode between VBUS and VSYS. Otherwise, the same precautions should apply as when connecting to VBUS. This is an example circuit which uses the 3.3 volt power supply taken from pin 36. In this case, there's a bright LED which is switched through a MOSFET. This needs to be an external circuit, as the GPIO pins on the Pico will not be able to switch the large current needed by a very bright LED. The circuit is taking power directly from pin 36, which is a 3.3 volt power supply. As I mentioned previously, it's recommended this is only used for 300 mA of current from pin 36. Now looking in the opposite direction, how can we power the Pico from an external DC power supply? This could be from a bench power supply, batteries, or from taking power from any different DC source. To do this, you need a power supply between 1.8 and 5 volts, as mentioned when we were looking at the specifications. Depending upon the circuit, you may also need the voltage to be a little higher than the 1.8 volts, which I'll explain at the appropriate circuit. I'll be using a power jack to represent power on the next few diagrams, but that could be batteries or any other power source. First, let's look at connecting power to the VBUS pin. You could do this with a suitable 5V DC power supply, but it's something I'd recommend against. The reason is that this connects directly to the USB on the Pico. So if you connect an external power supply and USB at the same time, then you're connecting two power supplies together, which can be an issue. You may think that you wouldn't want to, that you'll only ever use one supply at a time, but perhaps you've powered up your circuit, you just need to make a quick change to the code. So you're quickly connecting the USB, forgetting to disconnect the external power supply. Or perhaps you have an external circuit that needs a lot of power, so you disconnect the external power supply, but then connect it to USB, and the USB supply will be powering that external circuitry. If I don't recommend using VBUS pin, then what do I recommend? A better solution is connect to the VSYS pin using a Schottky diode. In this example, a 1N5817 diode. In this diagram, I've shown the diode mounted off the breadboard. That's just because it makes it easier to see. If using a breadboard, you should be able to bend the pins directly into those positions on the breadboard. Using this, we have the Pico Schottky diode between VBUS and VSYS, which prevents the external power supply from backfeeding to the USB power supply. And then we have the external Schottky diode protecting the external circuitry and power supply from taking power from the USB power supply. There will be some voltage drop through the diode. The actual amount varies depending upon the diode and the current, but we can say between about 0.2 and 0.7 volts. That means your power supply should be at least 2 volts or higher to be able to still have 1.8 volts at the buck boost converter. In terms of lost power, then for most users of the Pico, this will only be a few milliwatts, so it's not going to be much concern for most circumstances. There is an alternative circuit which I'll look at later. If both USB and external power are connected, then whichever is the higher voltage will end up powering the Pico. Finally, here is an example of using an external power supply to power both a Pico and a NeoPixels strip, done in a USB friendly way. Consider that the NeoPixel strip may have 100 or more LEDs, on which would be far too much for the computer USB connection. I've used a different ground pin on this example, mainly because this is based on a diagram I did for an earlier video, but it also looks a bit clearer with the ground away from the power connections. In this configuration, you connect power through the USB connector, but thanks to our external diode, it won't be able to power up the NeoPixels. This will allow for programming the Pico without risk of exceeding the USB power supply. The external power supply can be connected without the USB connection, which will power both the Pico and the NeoPixels. And finally, you can connect both power supplies. The external power will run the NeoPixels, and then the Pico will take power from whichever of the two power supplies has the higher voltage at VSYS, which is after the diodes. This allows for programming and debugging whilst the external power is connected to the NeoPixels. Ideal. I'll finish by looking at a few more specific situations. What to do if you have an AC power supply instead of DC. What to do if your DC power supply is not at the correct voltage. An improved external power connector circuit. How you can bypass the diode to reduce the amount of power loss in a low power USB situation. How you can use the Pico's 3v3 enable pin to turn it on and off. And finally, some other considerations and things you may want to think about when looking at powering a Raspberry Pi Pico. If you have an AC power supply but would like to use that to control your Pico, then you can use a full wave bridge rectifier to convert from AC to DC. I won't go into detail here. I've already created a video which covers this in detail. The video is part of my model railway automation series. In the first video, I show the difference between AC and DC, how a full bridge rectifier works, and how you can use a capacitor to provide some smoothing. If If you have a DC power supply, but it's not within the correct voltage range, you can use an external buck converter. You could also use a buck boost converter, but considering the minimum voltage is only about 2 volts, it's more likely you're going to reduce the voltage than increase it. This example has a variable input which can drop the voltage down to 5 volts, ideal for powering a Pico from a 12 volt power supply. It has a USB connector for the output, which can be used to connect through to the micro USB on the Pico. On some other boards, you may have the output on a screw terminal connector instead. There are many different types available on eBay or your usual electronic suppliers. Here is an alternative circuit design, useful for connecting an external power supply to Pico when it may also be connected via USB. This is taken from the Raspberry Pi Pico datasheet. It uses a P-channel MOSFET which connects the external power supply to the VSYS pin, just replacing that diode we used before. If there's no power on the VBUS, then the MOSFET will conduct, connecting the external power supply to VSYS. If there is power on VBUS, essentially if it's connected via USB, then the gate has a high voltage causing the MOSFET to turn off. I'm happy with the diode in my current project. It's easy to use on a breadboard, but this is something you may want to consider if you're creating your own PCB. In the datasheet, they suggest using a DMG2305UX MOSFET. If you're looking to get the most out of a USB power supply, then one thing you can do is to bypass the diode between VBUS and VSYS. You should only do this if you're not planning to connect a second power supply, and it will not make a huge saving. But if you're needing low power, then it could help just a little. Just connect pins 40 and 39, VBUS and VSYS together, and you'll save a small amount of energy by bypassing that diode. One thing you may want to consider in a remote low power situation is that there's a way of powering down the Pico using the enable pin on the buck boost converter. This is pin 37 on the Pico, known as 3v3_EN. It's shown at the centre of this diagram and is currently pulled high through a pull-up resistor. If you pull that low, then it will disable the buck boost converter and only a tiny amount of power will be used by the Pico. Why would this be useful? After all, you need some way of pulling the enable pin down. One way I can think of is if you've got a remote monitoring station. It needs to send a signal back if a certain condition is met, and you are using a Pico wireless to send that signal to another location. You could have a very simple low power circuit which just monitors for that condition to arise, which then powers on the Pico so that it can read the information and send it back. Or you could have a simple low power timer which turns the Pico on for a certain length of time each day so that it can perform a certain function and then power off. I suspect there won't be too many that need this ability, but it's there if you do. You may also want to consider the low power states that the Pico can be running as an alternative. Details of that are included in the Pico datasheet. Some other things you may want to consider about powering in the Pico is that the Pico has a very low power requirement, so it's ideal for remote monitoring applications where you may not have access to mains electrical supply. In that case, you may want to run it off batteries or some form of renewable energy supply. Whilst powering through VSYS will allow for a wide range of voltage, if the power is intermittent or is prone to energy spikes, I would suggest using some kind of battery-backed solution. Effectively, using the renewable energy source to charge battery, which is then used to supply the Pico. There are some commercial products which are available. This is an example from Waveshare, designed to be used with solar panels. They also have a version which comes with an enclosure supplied with or without the LiPo battery. I haven't tried that particular board yet, but it's something I may look at in future. Also, a quick warning about lithium-based batteries, such as lithium-ion and lithium polymer batteries. These batteries must have protection against over-discharge, overcharge, overcurrent and overheating. If not, there is a risk that this could cause fire or explode. Whenever using these batteries, please ensure you have appropriate precautions in place to protect the battery and the environment you're working in. I hope you found something useful from this video. If so, please hit that like button, which can really help with the YouTube algorithm. Please also leave a comment if there's anything new you've learned or you have any other suggestions for ways of powering the Pico. I'm currently working on some projects based around the Raspberry Pi Pico. So if you'd like to see any of those, please subscribe and enable notifications to find out about my new videos. Thanks for watching, and I look forward to seeing you on a future video.